Okay, so we have 3 problems to do, and this is the first one. For this system, we have to write an augmented matrix and solve using row operations. So let's rewrite this in the form of an augmented matrix. So the coefficient on x is 1, on y is 3, and then we have a -2. Coefficient on x is -4, coefficient on y is -5, and we have a 7 as a result. And here's our augmented matrix. Now we've got to manipulate this, and we'll use the first row to get a 0 in the first column in this position. So the first row isn't going to change. But when we're done, we'll have a 0 right there. And now let's write down that second row. It is -4, -5, and 7. And we've got to do something to the first row such that when we add the 2 rows together, we get a 0 right there. So we'll multiply that first row times 4, and we'll install the notation here. So 4 times r sub 1 plus r sub 2 will replace r sub 2. So 4 times 1 is 4, 4 times 3 is 12, and 4 times -2 is -8. Let's add them up. We get 7 and -1. So now we put a 7 here, -1 there. Now, we need a 1 in that position, by the way. So 1, 3, -2, 0. And as I said, we need a 1 here. Well, what can we do? What can we multiply this second row by such that we get a 1 in that position? Well, we'll multiply by the reciprocal of 7, which is 1/7. So 1/7 r sub 2 will replace r sub 2. And so -1 times 1/7 is -1/7. Now, what does this tell us? Well, this implies that y equals -1/7. And our task now is to find x. So we'll rewrite this row in terms of x and y. So 1 times x is x. 3 times y is y, 3y. And equals -2. Now in place of y, we'll install this -1/7. So x plus 3 times -1/7 equals -2. So x and 3 times -1/7 is -3/7 equals negative. Now, how many 7ths in 2? We've got to get a common denominator. Will you agree that, and it'll be negative, there are 14 7ths in 2. If we reduce that, we get a 2. So now look, we have a common denominator. So adding 3 7ths to both sides, we get x equal to -11/7. So we have our y and we have our x. So the ordered pair, the point where these 2 lines will cross, will occur at -11/7, -1/7. And we're done with that one. But before we quit, let me point out that As an exercise, replace x with negative 11/7, y with negative 1/7 in each case, and verify you do get the appropriate negative 2 and 7. Well, for the second question, we have to use Cramer's rule to solve this system. So let's do that. So x will equal, and we're going to have a quotient of determinants, and the determinant of the two expressions on the left of the equal sign is made up of a 2, a 1, the coefficients on the variables, and a 5 and a negative 1. In the numerator, we exchange the result column for the first column, so we get a negative 7, but the y column remains unchanged. And for y, that's going to equal, and we'll have the quotient of determinants, and we'll have the same denominator, the determinant of 2, 1, 5, and negative 1. Let me make it better, 2. There. Okay. In the numerator, the x column will remain unchanged, but we'll exchange the result column for the y column, negative 7, negative 7. Now, let's compute the numerator for x, and that determinant of negative 7, 5, negative 1 equals, and the product of negative 7 and negative 1 is 7, and minus, and the product of negative 7 and 5 is negative 35, and that equals 7 plus 35, which equals 42. So let's compute the numerator for y. And that's the determinant of 2, 1, negative 7, negative 7. And that equals the product of 2 and negative 7 is negative 14 minus, and the product of 1 and negative 7 is negative 7. And so this equals negative 14 plus 7, which equals negative 7. Now let's compute the determinant we find in each denominator. And we'll install the values 2, 1, and 5, and negative 1. And that equals 2 times negative 1 is negative 2 minus, and 5 times 1 is 5, and so that equals negative 7. So now x equals the quotient of 42 and negative 7. So x equals negative 6. For y, we have the quotient of negative 7 and divided by negative 7. And that equals 1. So our ordered pair x, y equals negative 6 and 1. Now, as an exercise, install those values in for x and y and make sure you get the appropriate results to verify we've done this correctly.